So I'm Roi Tabach. I joined Hunters around 3 years ago. Um, the slides will be published with my email if anybody has questions after the talk. So what are we going to talk about today? Go over who's in the crowd, what's a SOC, and what's Hunters, how we use isolation forest to help us with lead scoring. Obviously, we'll also explain what it is. Why do we need explainability in machine learning in the cyber domain? How we use SHAP for it, and general notes about explainable AI. Okay, so I feel like there's justification for me making this slide, which says what's a SOC. Basically, SOC is an acronym for System Operation Center. I hope it's the right one. In Hebrew, it's Hamal for the Hebrew speakers in the crowd. What does it mean? Basically, a serious organization that pays vendors to protect, for example, its email or its endpoints or its usage of cloud, its APIs, if they pay salt. So they usually have some sort of internal team that looks at alerts that come in from vendors and try to decide what to do with them, sort of triage. Like in Roman's example from the talk before me, if they reach a point where they call the CISO of a large bank in the middle of the night, usually it will be someone from his team that is doing some sort of shift calling him. So a lot of the times it's well, before the COVID, it was a large room with a ton of screens. Now it's like a Grafana dashboard maybe, but anyway, the blue team of an organization uses the SOC or is the people that man the SOC and use it to triage alerts, create incidents, decide what to do, and resolve them. So these people are bombarded with the alerts of all the vendors that they decided are important to pay. So it's actually a role that is very tiring and taxing, and people usually burn out of it. Like the burnout rate for SOC analysts is around 1.5 years or 2 years. So this is something that basically Hunters tries to solve. So Hunters is called the SOC platform. Basically, it means we hope the SOC people join or open Hunters and work from there mostly. And what does Hunters actually do for this blue team? So I'll have a running example in a second, but first let's talk about what is Hunters. So basically we get a feed of alerts from vendors that our customers use to protect themselves. For example, security products such as API protection, email protection, endpoint protection, network, everything. We get them into Snowflake, and we have an engine that does stream processing based on Apache Flink running on top of it, creating alerts. We also get a ton of alerts from the vendors. We take all these alerts and we want to show them to this, basically to the SOC analyst, but we don't want to just be like blindly forward the alerts to the SOC analyst. We want to help them because they're bombarded with a ton of alerts every day. So what we do is we start investigating each alert and we try to prioritize it. And we try to figure out how different attacks correlate to each other, create what we call attack stories. And then we also forward it to the analysts and to some automated responses. So today I'll mainly talk about how we prioritize events and alerts. So let's get with a running example. So, okay, we have two feeds in this example that we get from our customers. One is a feed of access to AWS Console. So AWS Console, basically the web app used to control AWS resources. Everybody that does a login to AWS Console or does any action inside it, we get a row appended to some DB. And we get, for example, the username, like who did it, and from what browser and OS did they go. This data like they send, so but we can decide to trust them, and what source IP they came from. And for customers that have an EDR agent installed, we also get a feed of the devices, let's say once per hour. Every EDR agent installed on a laptop of employees calls home and tells them this local username is living inside this IP. This is the OS version, maybe some other configurations. Okay, so what can we do with these two feeds combined? I think there's no realistic way for the audience to answer, so I'm going to be quiet for 10 seconds and then reveal the answer. Cool. So what can we do with these two? So we can try to look at the group of IPs that were used to log into AWS and do a subtraction of the group of IPs that were reported to have EDR agents installed. And what will we find is the group of IPs that people use to log into AWS to control company AWS assets without having an EDR agent installed. What could it mean? It could mean that the EDR agent crashed for this specific hour. Maybe he didn't report. Or it could mean that the employee is working from his phone on AWS, which would be not something I've never seen before. Or it could mean that an attacker somehow got his hands on an employee's password, doesn't matter how, and now he's using it to log into AWS console. Obviously, the attacker doesn't follow the company policy, so he doesn't have an EDR agent installed. And in this case, we may catch him this way. So this subtraction of groups is expected to be empty most of the time, but it's not going to always be empty. And I don't want to just bombard the analysts with false alarms all the time on this. So what do? We auto-investigate. How do we auto-investigate? Basically, we have an infra that allows our cyber researchers to add different things that they want to enrich our leads with. We call this, each instance of this alert, we call it a lead, and we want to enrich it, for example, with, if it comes with an IP, we want to know what geography the IP is from. What country, for example, if it's from Nigeria and the customer doesn't have any office in there, maybe it's more suspicious, I don't know. We also have the ability to enrich not only with external APIs, but with internal data. For example, did any other employee work from this IP? Did anybody log into a different web app, not AWS console? Maybe they also have Azure shop. So did anybody log into Azure from this IP? We also can try to parse the user agent to understand if it's persons actually logging in from their phones. We can try look for cases where there's some strange load balancing that sends the EDR agents reports to appear from one external IP and the AWS activity from a different external IP. So we can apply some heuristics to not show all these alerts to analysts. What we
Roi, you're mute. Yeah. Right.
For how long was I muted?
1 second.
Cool. Okay, so basically we can apply all these heuristics, but as we've seen, it wasn't enough. Like the amount of false alerts that we showed the SOC teams of our customers was still something we thought is too high. So on to our next slide. What did we decide to do with it? So basically what we decided is to score leads with isolation forest. So maybe we'll talk first of all about what is isolation forest. Isolation forest is the less known cousin of random forest, which is a really well-known machine learning algorithm, I think. Anyway, the idea in isolation forest is if you look at the data set and you imagine that all the dimensions are only 2, so you can look at clusters of points and you can assume that a normal point would be sort of in the middle of all the points. So if you want to separate it from the other points using lines in the 2-dimensional case or hyperplanes in the n-dimensional case, you would need a lot of hyperplanes to separate it. So in this case, like a normal point that's in the middle of all the other points, in some sense, is sort of needs 4 hyperplanes to be separated, whereas a point that really looks anomalous, like it looks a bit separated from the rest, only needs 1 hyperplane placed in the right place to separate it. So basically, a separation tree is taking some of the features and trying to separate in some subset of the data, and then all these trees together are a separation forest or an isolation forest. I'm not going to dive really too much into it, I think, given the time limitations. We use features. So just to be really clear about it, the data points that go into the isolation forest in this case are leads, like alerts. So it's suspicious activity anyway. And we extract features from this lead, IP-related features such as, was this an IP that is a known proxy, or what geolocation did this IP come from? User agent related, is it, what OS version is it? What major browser version is it? We apply category encoding on it, so nothing, like we didn't need to pull any heavy cannons on it, and it works well enough in separating. What does it mean? It means that when we look at the leads that come out as anomalous in the isolation forest, all the other leads that come out as non-anomalous really should be at the bottom of the SOC queue. The SOC analyst probably won't get to all of them in his day, but the leads that come out as anomalous can get their score raised and then to float up to the top of the feed of the analyst. Cool. Okay, so this is really interesting, and we actually, it's one like piece of research that I'm very proud of. But what is the relation to explainability? So why explainability? Historically, analysts usually doubt AI, specifically in the cyber domain. If you take a veteran analyst, like a SOC analyst that's in the industry for over 5 years, I mean, they're rare, but they exist. If you tell them that your solution is AI-based, they would laugh at you basically, or just like forward it directly to DevNull. So even today, like users that get an alert from a black box have a hard time trusting it. We saw it where we have an internal threat hunting team that also looks at data and alerts coming in from vendors and tries to hunt the bad guys on our customers' environment. So our own threat analysts get different kinds of alerts from vendors, and we saw that when the alert didn't get with any explanation except for the magic string machine learning, our analysts really didn't know what to do with it, and usually they didn't put too much time into investigating it. So explainability can be related strongly to actionability. I mean, if I can explain that the suspicious part of this lead from all the other leads was that it came from Nigeria, the user can do something with it instead of just me saying, oh, that's the top score because machine learning. Also, actionability for the machine. So in Hunters, we have the ability to drill down on some aspects. So for example, if I find out that the suspicious thing was the IP, I can now automatically go back to the data and ask follow-up questions on this IP that maybe cost too much in runtime to run on all the leads that we generate, but for leads with a high score, maybe it does make sense to do. Okay. Let's talk a bit about explainability in general before going into SHAP. So it's really important to know who we are trying to explain to. Super important to know if it's internal or external, because with external, you can't have any embarrassment. You can't have even spelling errors, but in general, internal have a higher tolerance to things that make little sense to them. Also important to know if the people who are supposed to consume the explainability are experts versus novices. For example, one solution to hide some advanced stuff behind some plus sign and hide it in some corner, so only advanced users will actually know how to find it. But anyway, we want to show external readers stuff that they can understand and usually that are actionable. So for example, if one of the things I use is the entropy of the command line, I don't know. So if I didn't explain to the user what is entropy and why it's important, they won't understand it, and the explainability would actually make the situation worse instead of better. Also, it has to be actionable. If it's for an internal team, it's actually a feature because, except for being able to put on all the features, even the ones that make little sense, because they can always go back to you and ask you, you can use them to actually debug the features values. So if you have, for example, a labeling team, you can show them the features extracted, and then they can do a sanity check over it as well, or professional services team, etc. in general, what we found is really useful is to use templates instead of strings. So if we have a string that makes sense to us, but makes little sense to English readers, some sales engineer or product can actually replace the string without us having to change all the backend. And if there's a concept that we used to engineer the features, actually sharing it along with the feature value. For example, the suspicious thing was the geo country, and we found that attacks come from Nigeria if the customer doesn't have offices in there. So stuff like that. Okay, I see I have only a few minutes left. I can talk about SHAP, but also I want to have time for questions in the end. So what can I say about SHAP? First of all, it works really well on trees. So both random forest and separation or isolation forest works really nicely with it. And it's really easy to use without understanding it completely. I won't go on to the game theory behind it because I really don't have time. SHAP has two features, local explainability and global explainability. Basically, these images are from our blog post about how we do it. So basically, local explainability means using SHAP to tell us in this specific prediction what features values made the anomaly score higher and what feature values made the anomaly score lower. So in here you can see a made up example of two logins, one where the MFA, the login had an MFA included with using a YubiKey and from a normal, let's say, country, which is England, and Chrome on Windows, and an anomalous example where the country was Spain, which is unusual, and the MFA method was an SMS, which is less common. And also, if we show this to the analysts, they can say, oh, SMS is very suspicious because it's an attack vector that's now very common. Global explainability basically means, I think I don't have a slide for it. Yeah, global explainability in SHAP basically means after training a model, asking a general overview of the features, which one is the most important, etc., which can be really used if you train a model, for example, every day or every week to debug changes in the data that, for example, caused some feature to be really important where it wasn't important before. So you can have an alert for that and have an analyst look into it and find out that this column became all nulls in the data. So now it, for example, looks different. That's all. Questions?